All right, this is Dwayne, and we're doing Unit 1, Lesson 8. And in this lesson, we're going to be digging into that area of the triangles kind of formula. And we're going to it's really getting to that standard algorithm is where we're getting that formula. But we're going to get there through discovery. So let's get started. So we're going to begin with just a warm-up, composing some parallelograms. And so we've got right here, we've got this wonderful little triangle M. And it says Han has made a copy of triangle M, and he's composing a bunch of different parallelograms. And we got to find the base and the corresponding height for each of these. And then we're going to find the area. All right. So let's zoom in. And so, well, the base is pretty straightforward. Right here is the base. Right there is the base. And right here is the height, because it's got to be that perpendicular line, right? So that one's pretty straightforward. But what about this one? So this one, we've got to look for our base and its perpendicular line, which gives us the height. So we have some choices here, don't we? On this one, if we want, we could say, here's our base. And what's our perpendicular line? Our perpendicular line is a thing that goes like this. And so where's the height? The height, boom, right there. Really, any of these would represent the height. And I'm not the whole purple line. Maybe I should erase that purple line and just say here. Right there. And so that is our height. Anywhere along this parallelogram is our height. Was that the only answer? No, that was not the only answer. We could have essentially done, well, let's zoom in. We could have rotated that, and we could have said, well, here's our base. And if that's our base, then what is our height? Our height would be like that. And so there is our height right there. Boom, right there. Boom. So that's our parallelogram, base and height. So maybe I'm going to label this B, and I'm going to label this H as our height. It's kind of weird that our height is the thing that's going left and right, as our height, and our base is the thing that's going up and down. So that is a little weird, but that's cool. All right, and then what about this parallelogram? Well, the base, let's do it in blue. The base, we could do this as our base right here, but technically from here to here is our base, and then that means this thing right here is our height, and that's our height. So I'm going to put H for our height. There we go. And now what is the area? Because it says we have to find the area. So all we have to do is take any of those bases and any of those heights. So let's do this one because it kind of seems to be the simplest. The base is 1, 2, 3, 4, 5, 6. So the base is 6. The height is 1, 2, 3, 4. The height is 4 units. So the area is base times height. In this case, it was 6 units times 4 units, which gives us 24 square units. The area of all of them is going to be the same because it's the same two triangles making those parallelograms. In all cases, our answer is going to be 24 square units. All right, so now on this one, it says we're supposed to find the areas of at least 2 of the triangles below. Show your reasoning. So we remember that a parallelogram is base times height, right? And since an area of a parallelogram is base times height, and the triangle is going to be half of that parallelogram, all we have to do is find the parallelogram. There it is. In this case, it's a rectangle. Find the area of that entire thing, and then divide by 2. So our base is 1, 2, 3, 4, 5, 6, 7, 8. Our area is 8 units by 2 units, which gives 16 units squared, but that's the entire parallelogram. So now we're going to divide by 2. So now the area of the triangle is going to be 16 divided by 2. I was going to write it as a fraction, then I changed my mind. And that gives us 8 square units. Super simple. Ooh, this one. All right, well, we got to find our hidden parallelograms, right? And so on this one, we have a choice. We could, if we choose, we could take the original triangle, and just like in our warm-up that we just did, we could take it and then we can, whoa, sorry, it's all goofy there, but then we can double it. So now we have a parallelogram. And so our base of this new parallelogram is 1, 2, 3, 4, 5. So the area of the parallelogram is 5 units by, and I don't know what the height is. Let's count it. 1, 2, 3, 4. So it's 5 by 4 is our parallelogram, which is 20 square units. So the area of the triangle is going to be 20 divided by 2, which is 10 square units. All right, so was that the only way to get that answer? No, there's other ways we could have done it, but I'm just showing you one way because math is cool that way. All right, now this is kind of cool. We got to find our hidden parallelogram. And there's a couple of ways. We could create 2 parallelograms. There's one right there. And then a second one way over here. So we could have created 2 parallelograms and find the area of each triangle inside each of those parallelograms and added them together. That's one way. But we could also do, boom, look at that. We create a whole parallelogram right there, all at one stop. And we can see that the base of this parallelogram, base of the parallelogram, which happens to be a rectangle, right? So the base is 1, 2, 3, 4, 5, 6, 7. The base is 7. The height is 1, 2, 3. So the area of that parallelogram is 21 square units. So the area of the triangle is going to be half of that. So 21 divided by 2 gives us what? 10.5? 10.5 square units. All right. A variety of ways to get that. I just showed you one. And then here we go. So I can see a nice, easy look right here. There is, boom, there is my rectangle or parallelogram. I could see the base is right here, and it's 4 of that. Well, I don't have to call that a base. I could call it height if I wanted to, huh? But I was really kind of looking at that kind of gives you insight as to what I was looking at. I was looking at the triangle, and then I was seeing this as the height of that triangle, and that height is 6. So the parallelogram is a 4 by 6 parallelogram. So the rectangle, the area of that parallelogram is 4 by 6, which gives us 24 square units. But the triangle is going to be half of that. So 24 divided by 2 gives us 12 square units. All right. Now, students, you guys are all supposed to do only 2 of them, but we're just walking you through choices for all of them. So now here, all students parents and teachers, we're going to spend a long time, 25 minutes or so, on this activity right here, because this is where we really want to get students digging deep into this. And really, this part 2 right here, that's about 25 minutes as well, as I recall. So that's a lot of work. I mean, this is not just random brainless practice. We're really asking our students to dig into this stuff. So first thing we're going to do is we're going to try and find the area of this entire parallelogram. All right, so we see that the base of this parallelogram right here is 10. It's not super obvious, but we can see that the height of this, the height of this parallelogram is 8. So the area of our parallelogram is base times height, which is, in this case, 10 times 8, which gives us 80 square units. And actually, since they tell us the units are centimeters, technically we shouldn't have a U, we should have a cm for centimeters squared. So we've got 80 centimeters squared. All right, so that's the area of that initial parallelogram. Now here, the directions are we got to take it and we got to cut all along the dotted lines right here. Cut up all the dotted lines. And then we're only going to take the small triangle and the trapezoid. Now, parents and teachers, heads up. Honestly, full disclosure, I misread it. I didn't see this. I thought I was just supposed to create this triangle and this whole triangle. It was quite some time before I realized, no, I was actually supposed to also cut this apart to create a trapezoid and a triangle. And what we're supposed to do is we're supposed to create a new shape, what does it say? Create a new parallelogram. So I'm going to take this guy and I'm going to rotate him. And I'm going to slide it right there. So now I have a new parallelogram right here. There's my new parallelogram. And we're supposed to find the area of that new parallelogram that we composed. And so we can see that the base of that parallelogram right here is 10. We can see that the height of that parallelogram is 4, because there we go. Anywhere I slide it, it's always going to be 4 units tall. And so the area of that new parallelogram is going to be 10 times 4, the base times the height, which gives us 40 square centimeters, or 40 centimeters squared. Right? Now, what do we notice about this, the area of this new parallelogram compared to the one way up here? Well, we can see that it's half, isn't it? The original one up here was 80, and now this new one is 40. So we can see that it's half. And how do you think that the area of the large triangle compares to that of the new parallel? Oh, what do you notice about the relationship between the area of this new parallelogram and the original? How do you think the area of the large triangle, the large triangle compares to that of the new parallelogram? Oh, okay. So what they're saying is, so if we know that this guy right here has an area of 40 square centimeters, the big question is, then what's the area of this guy right here? Right? It's going to be 40, isn't it? Because we know that we started here, which was 80, cut it in half right along here. So that means this is 40 and this is 40. So there's our relationship between the parallelogram and the triangle. So we're supposed to glue everything and use it, and show our work and all that sort of stuff. So we already did that. All right, and we're going to skip. Can you decompose? This is kind of a cool one. Can you decompose this triangle and rearrange its parts to form a triangle? To form a rectangle. Describe how this can be done. So there's some pretty awesome GeoGebra applets, and I will put one in the show notes here that will lead directly to a beautiful applet that kind of helps visualize how we might consider changing this triangle into a rectangle. It's really a beautiful applet. So I'll find that and I'll put it in our show notes. But it's going to be on I'm going to find it at geogebra.org if you want to go ahead and do some exploration yourself. So this is the lesson summary about everything that we were supposed to have learned, and the idea that, by the way, this visual might help you with how we can take a triangle and turn it into a rectangle. Because if you can take a triangle right here and then turn it into a parallelogram, then we can take this parallelogram and turn it into a rectangle. So it's a two-step process, isn't it? So first you turn it into a parallelogram, then you slice it further and turn it into a rectangle. That's actually kind of cool. All right. So that's all the review and the summary, and that's kind of important. So I'm going to let you, parents and teachers, go through that with your students. Let's do some practice. So to find the area of this right triangle, Diego and Jada used different strategies. Diego drew a line through the midpoints of the two big long lines, and then he kind of decomposed it. And Jada made a copy of it, and she took this and she made 2 of them and turned it into a parallelogram. Explain how Diego might use his parallelogram to find the triangle. So, and then we're supposed to, explain how Diego will use his formula or his technique, and explain how Jada is going to use her technique. All right. So Jada, when he took the original triangle and modified it and turned it into a parallelogram, he didn't add any extra area, did he? So his parallelogram is going to give us the area of 12 square units, or I guess it's feet, so it's really going to be 12 square feet. 12 square feet, but he doesn't have to do anything with his answer. He's done because he didn't add any fake area, so to speak, to get the parallelogram, his new parallelogram. Whereas Jada, what is she going to have to do? Well, she kind of doubled the original, she doubled the original triangle to create a shape that has twice the area. So when she does the math, she's going to get 8 times 3, which is 24 square feet. 24 square feet. But now she's going to have to divide by 2 because she doubled the original area by putting in this extra triangle here. So that's why she has to divide, because she kind of doubled the area. All right, so so they both get the same answer, but they have to handle that parallelogram in a different way. So 2A, find the area of the triangle. Explain your reasoning. So we can see that, well, here's our rectangle. 1, 2, 3, 4, 5, 6 has a base of 6. 1, 2, 3, 4 has a height of 4. So that means the area of the triangle is 12 square units. How did I get that? Well, 6 times 4 is 24. So the original rectangle, the area of the parallelogram, is 24 square units. So you got to divide to get the area of the triangle. Ooh, what are we going to do here? Holy moly. We know we can always double the original triangle to create a parallelogram. So there's our original, and there's our new, and we can see that that new parallelogram has a base of 1, 2, 3, 4, has a height of 3. So 4 times 3 is 12. So the parallelogram is 12 square units, which means the area of the triangle is 6 square units, because we have to divide by 2. Which of the 3 triangles has the greatest area? Show your reasoning. So basically, parents and teachers, we have to find the area of each of these triangles using whatever techniques we want to find the area of those triangles. Although I just kind of gave you some insight. Look at that. Look at each of the rectangles that can be created, or each of the parallelograms that can be created with those triangles. Are you starting to see a hint as to what is the greatest area? I'm going to leave that to you, because that's a juicy problem for you to work on. But it does say, if you get stuck, just find the area. Find the area of all the triangles, which is really half of the parallelograms, right? So here, number 4, draw an identical copy of each triangle such that the 2 copies together form a parallelogram. All right, so we got to make an identical copy. So there's my original triangle, and I make a copy of it, and let's see. What do we do? We go, oh yeah. There we go. Done. All right, now because that's a little funky, let me do that in a different color, because that's a little funky. So I'm going to do this one in green, and then I'll do these 2 in blue. And now you're going to see, because what we need to do is we need to rotate it so that it's green on green. There you go, like that. That's how it's going to look. And that's our new parallelogram. We could do the same thing here, and we could do the same thing here. So I'm going to let you do that on your own because you don't need me to do all of them. And then finally, question 5, a little bit of review. A parallelogram has a base of 3.5 units, and its corresponding height is 2. What's the area? So we know we just multiply those 2. And the parallelogram has a base of 3 units and an area of 1.8 square units. What's the and an area of 1.8. So what's the corresponding height? So what are we going to do? Well, we know that if the area of the parallelogram is base times height, and we know that the base is 3 units, and the area is 1.8, and we don't know the height, so we have to find the corresponding height. So what kind of math are we going to do to figure out that 3 times what gives us 1.8? So we're going to use a little bit of We're going to use a little bit of division to figure out what that missing corresponding height is right there. All right? So I'll let you do the division. You don't need my help on that. And then lastly, a parallelogram has an area of 20.4 square units. If the height is 4, what's the base? Same exact problem, but slightly different details. The area of a parallelogram is base times height. We know that the area is 20.4. We don't know what the base is, but we're told that the height is 4. So right here, we know that base times 4. So something times 4 gives us 20.4. Woo! So we're going to use a little bit of division to figure out what that missing base is. And that wraps up this wonderful lesson number 8. It's learning all about triangles.